Oh, my name's Carl Hoff. The community is the soccer community to introduce myself and introduce some of the twisty puzzles that I've worked on. I'm very grateful for that opportunity. I'm a first-time IPPer, and I've received a really warm welcome. I'd like to thank everyone for that welcome that I've received. I want to basically talk about how I got my start as a designer. I'll go through a few of the puzzles that I have designed, and then talk about some of the puzzle ideas, some of which I've designed, but haven't yet turned into physical puzzles, and a roadmap for the new puzzles that I'd like to make here in the near future. This is my first puzzle design that I made. This dates back to 2007. At that time frame, I was using software provided by Hoff. It's a free ray tracing program. It does not allow the export of STL files, so this stuff I couldn't make as 3 files, but or physical models. But the idea that I was trying to make here was to allow someone to play with the 3x3 that's inside a 5x5x5. A 5x5x5 should have 125 cubies. You actually only ever get to play with 98 of them. The rest of them are hidden inside. So the mechanism that came up here was a tongue and groove technique to interlock the outer cubes all together with nothing on the inside of it. This is what the corners would have looked like. This here is one of the edge pieces. This here is the middle edge piece. This here is the X face center. This here is the T face center. And this is what the T centers would look like. So you could, in principle, put all these together. You'd have a 5x5 cube, which would be totally void on the inside, 3x3x3. When I actually presented this on the forums, I presented it as a new mechanism for a 3x3x3, which allowed all 27 cubies to be identical. The normal Rubik's cubes, the corner pieces are uniquely a unique shape, the edge pieces are a unique shape, the face centers are a unique shape, and so on. Here you could actually fill this void with a set of dice, for example, and have a fully functional 3x3x3 where all the cubies were identical. I never actually made this. It was well received on the forums. It's a great concept, but in practice I don't think it would be a very good idea to try to make a 5x5 this way. I will revisit this idea here soon, but this was my attempt to basically turn what Tony Fisher called the hidden cubes into an idea that could be a playable puzzle. Now, this here is actually the first puzzle that I made. I designed it in Hoff again, which I can't export. So these are some of the pretty Hoff pictures I made. This is actually the first design. You see there's voids here between some of the pieces which I'm calling the thorn, which are the green pieces. When this one was printed, it fell apart immediately. There was a second revision that was made. I changed some of the surfaces, so everything you see in this image here is yellow. Was the new surfaces that I put in on the puzzle, which allowed me to close those gaps on the surface. And it's more stable. I've got that puzzle with me today if anybody's interested in seeing it, but it still has a problem with pieces falling out of it. These are some pictures of the actual puzzle, but the basic idea here was to mix a circle cube with a mix-up cube. So I'm allowed to do 45-degree turns on the slice turns, and when I rotate one of the faces, which includes a special corner that I've colored it red in this picture, and the physical puzzle is the red, white, and blue corner. But if I turn a layer that includes that piece, the opposite face center circle will turn with that layer. It's basically a tongue and groove, or tongue groove mechanism here on the inside. Here's what the core looks like here. It shows you how it's attached to that red corner. And the face centers and the edge pieces slide over pieces that stick up onto the core where there's grooves on the feet of those pieces. The next puzzle that I made, this was and the first puzzle I actually made myself in SolidWorks. The previous one, I had to communicate with somebody via Skype to get them to actually turn that geometry into something that I could put into an STL file. But this is the Dr. Skew. The idea behind it was I wanted to make a mix-up master skew. And I basically, here's the first sketch I made. I do my sketching in Hoff as well. And I basically wanted to see, here's where the planes I want to cut. These are what the shapes are going to be like. And I basically started rotating pieces, applying the cuts again, and doing this technique, I ended up with a puzzle where all the pieces ended up being circular on the surface of the puzzle, which would allow the pieces to rotate freely. Oscar gave me a great suggestion. He said, the problem I'm running into here is the fact that these paths don't cross at 90 degrees. So the solution was, okay, if that's the problem, then all I need to do is make the paths cross at 90 degrees. So the paths that these pieces follow around the equator of the puzzle is no longer a plane. It actually looks like this. And where the pieces cross, they do actually cross at 90 degrees. It allowed me to turn the pieces into a shape that wasn't circular. So now I got a foot mechanism on these pieces that keeps them from rotating in place. It is one of my harder to turn puzzles, but it allows you to basically turn the slice layer by 30 degrees and then turn another slice layer. It assumes all sorts of weird shapes. Here's what it looks like when it's fairly well scrambled. It's not totally scrambled in that picture. Another thing I wanted to mention too, in all these slides, I've got a link to a thread where I talk about this puzzle in detail in the Twisted Puzzles forum. If anybody wants a copy of this presentation, just email me. I'll be more than happy to give you this link, or this presentation. It includes all the links to more details about this information. You can also ask me. Always email me any question you would like about these puzzles. This is the next puzzle. This is the Dr. Cube. I was asked what would I need to do to be able to free up the Dr. Cube so that I could have corner rotation. And instead of going that direction, I decided to go back and revisit the Master's Cube. Oscar's got a great fully functional Master's Cube puzzle, but nobody had made not a Master's Cube, a mix-up cube. But nobody had made a mix-up cube that only allowed slice turns. So this puzzle uses a mechanism very similar to the Doctor's Cube, but now the paths are planar, so it's simpler. And I can do 45-degree turns on the slice layer and continue to make other turns. One of the nice states of this particular puzzle is I was able to rotate a single edge pair. The pieces on this puzzle, since it's a slice turn only, are basically linked to the piece on the opposite side. So this piece here is always in locked orientation with the opposite edge. This face is linked in orientation with the opposite face, and so on. So this is actually a valid state for this particular puzzle. The next puzzle I got into was a deep duty axial 3x3. This came about from a discussion where we were having on the forums about the FUD minutes and the fudging minutes. And Landon made this drawing trying to basically indicate here where we get the pentagonal faces and the hexagonal faces of that puzzle rotating. He made a mistake when he made the drawing, is that he assumed the cut depths of those two turns were the same depth. They're not on the real puzzle. And that led to the creation of this drawing. And by looking at this drawing, I saw a bunch of new pieces that don't exist in a physical puzzle. And I said, okay, I want to make those pieces so people can play with those pieces in a real puzzle. I approached Oscar about trying to make this puzzle with the same geometry, and he basically answered, was there any other simpler geometries we could make this puzzle in aside from the geometry of the FUT minutes? And so I said, okay, I'll think about it for a bit. And I said, okay, can I do what I'm doing on this drawing and apply it to a cube? And the answer is yes. And so basically what I ended up doing is you think of the Rubik's Cube as having 6 face layer cuts. All those cuts are the same depth, and all the faces can be rotated by 90 degrees. So what I'm doing here is, okay, let's take the Rubik's Cube, and for one axis, make the face cuts at a different depth. So the axis that goes through the yellow and white face has a cut depth of basically 2 cubies on this puzzle. All the other axes have a face cut depth of 1 cubie. So you can't turn that plane between the 2 blue cubies right there. They turn as a whole. The slice layer is only the middle row here. And on the other axis, the middle row is actually 3 cubies wide. So what you've got there is a Rubik's Cube, or a 3x3x3, where you've got different cut depth. It's not a 5x5x5 puzzle. After I made this puzzle, it was quickly pointed out that what this is a superset for the crazy plus cubes that are on. So here I've got the Venus crazy plus cube, the white face here and the one opposite the yellow face, turn with the face, all the other ones don't. And you can actually map the pieces on this puzzle to the pieces on the deep uniaxial 3x3. In addition to that, you get some other pieces, like piece number 8 here does not exist on that puzzle. So this is actually a harder puzzle. This is a more complete puzzle. There's additional pieces to solve and the deep uniaxial over the Crazy Plus puzzle. So the next question came up, because I can map these to the Crazy Plus Planet series, what other Crazy Plus Planet cubes can I make with this set of pieces? The answer is I can also make the Mercury version. So the Mercury's only got one face where the circle turns with it, so I'm going to end up with a puzzle that's only got one face layer that's 2 layers deep. The opposite one, again, the single layer deep. So here I've now got 5 faces where I've got shallow cuts, and I've got one face with a deep cut. Here's a picture that shows you how the mechanism of this puzzle works. On the inside of this puzzle, after I remove a face, basically one of the faces facing you, you can see that the top 2 layers and the bottom 2 layers here are bandaged to the other pieces, so they all turn as a group. This one here, all I had to change was 2 pieces. Actually, this first design, D-Dimension 2, was actually designed by Tom Vandenzater. Tom Vandenzater. And this idea was presented, and Tom basically had the mechanism worked out, and probably within a week to 10 days, I think he had the mechanism worked out. So we ended up getting this up on Shapeways, and it's not for sale. Someone was asking me, could we make the other version? And I basically took his SolidWorks files, modified this middle piece and one of the face centers, and extended this down, and I now have a new puzzle by only changing 2 pieces inside the existing puzzle. The next thing that came up here is Anthony Villamarian started a thread on Twisty Puzzles called the CompuDyno Cuboid. So you think of this as a dyno puzzle where you're turning the cubes, and these were the drawings he presented in the first post. He says, is this puzzle possible, or he was interested in this puzzle, and he didn't know if it was possible to make this puzzle, didn't have a mechanism in mind, he was throwing it out for the designers who might want to take a shot at it. And the first thing that was pointed out was these edge pieces here, mid-turn, they're in a position where there's no foot that could connect to the rest of the puzzle, so you can't make it with planar cuts. So the next drawing he threw up was ones with spherical cuts. And I said, okay, you can make it look like this. And my response was, yeah, I think that's doable. Much of the forum was saying, well, you know, you're still going to have to fight the piece because you think of the core as being in the center of the puzzle. These pieces on here at this edge are further away from the core than the middle edge piece over here. So if this piece is going to move from here to here, it's got to be able to vary its distance from the center of the core, and you're going to have to fudge the puzzle. I said, no, I still don't think there's any fudging necessary. So I set about in a period from 10 days from the original post to when I finished my Pomfrey model, I made these pretty pictures here to show you what the inside of this puzzle needed to look like. It didn't require any fudging, but it does require this asymmetrical core. This core you can think of as almost 2 dyno cubes that have been fused together. These edge pieces, the inner edge pieces, not the outside ones, but they're restrained to only existing on one half of the puzzle. So there's 4, actually there's more than 4, but the ones on the top half of the puzzle stay on the top half of the puzzle. The one on the bottom half of the puzzle, they're stuck on the bottom half of the puzzle. The outer edge pieces, they're free to roam all over the puzzle. They exist in 2 orbits, but they can move all over the place. So this puzzle was realized in Pomfrey. It took me a year in the process of when I was learning SolidWorks to get it converted over to something I can print. But it now is printed, and this is the puzzle I've submitted to the design competition. So hopefully most of you have had an opportunity to play with that puzzle by now. There's a family of puzzles that can be made with that same set of pieces. This puzzle here is slightly longer. Instead of overlapping with 2 edge pieces on 2 axes, I only have it on 1 axis. Here, the overlap between this corner and this corner is just the 1 middle edge piece. Same for here, just a 1 middle edge piece that's shared between those 2 corners. So I call this the Bubbleoid 1-1-2 puzzle as opposed to the Bubbleoid 1-2-2 puzzle. The corners, like I said, again, are identical to the corners of the other puzzle. These yellow edge pieces are identical. The blue edge pieces are identical. The only thing I have to design is a new core to put the pieces on. And that puzzle has now been made, and I have that puzzle with me today as well, too. But that's what this puzzle looks like. Solving-wise, it should be a very similar solving experience to the other puzzle. This is another puzzle that I'm very proud of. Oscar has been presenting puzzles I've got some of the names of them on here. The paso doble, where all the axes are connected with a 1-to-2 gear ratio. He's got the slice gear cube, where he's got two opposite faces on two different axes connected with a 1-to-1 gear ratio. But on the other axis, he's got a direct connection with them, so they turn together. That's his slice gear cube. He's also got the gear cube, the anisotropic gear cube, and the even less gear cube. And my idea was, okay, Oscar's making all these great gears, but is there a way we can get them in a set where we can make all of these puzzles with one set of pieces? And he was nice enough and generous enough to provide me with a set of STL files that included the gears themselves. I then took those gears and combined them to get these different gearing ratios between the faces. And I've now got a puzzle with this set of pieces that allows me to build all 35 of these variants. I can leave the gears out, and if I leave the gears out, I have a normal Rubik's Cube. If I just connect two opposite faces with a 1-to-1 gear ratio, I basically have a puzzle that's equivalent to the even less gears puzzle, except I don't have the exterior gear pieces. The Rubik's Cube pieces themselves are all present. If I couple two opposite faces with a 1-to-1 gear ratio, I end up with the anisotropic gear cube. If I couple all the faces with a 1-to-1 gear ratio, I get the gear cube, which is one of the easier puzzles. It's one I can solve. I'm a much better designer than I am a solver. The slice gear cube, problem there is the way Oscar built it, he's got two opposite faces that are tied together, and I can't do an arbitrary tie together between all three faces that way. So what I ended up doing was using a 1-to-3 gear ratio to mimic the slice turn on that puzzle. So you can think of, if you turn one face 1/4 a turn, the opposite face does 3/4 turns in the opposite direction. It ends up in the same state that it would be as if they rotated together as a pair. So this puzzle, built with my kit, produces the same puzzle. It's just going to visually turn differently in between states. The paso double puzzle is in here as well. And you can make a slice turn only 3x3x3 with these pieces by just putting a 1-to-3 gear ratio on all the axes. I can put a 1-to-4 gear ratio on all the axes, and I'll end up with a fuse cube. A fuse cube is a Rubik's Cube where one corner has been fused to all the neighbors, so you've got a block, and it just allows you to turn 3 of the face layers. The 1-to-4 on all axes accomplishes the same thing. When I turn one face 4 times, it ends up back in the exact same state, whereas the opposite face has done a 1/4 turn. So the faces that you're actually turning, the ones that are making the 4 quarter turns, always end up in the same state. So it's a fuse cube without actually fusing those pieces together. Some of the puzzles I hope to build in the future, we can take the bubbleoid puzzle and go to one order higher. Here you see the bubbleoid 1, 2, 3 puzzle. Oscar's built the puzzle, essentially, it's the same puzzle. The appearance is different. He calls it the, it's the mosaic block puzzle. And it turns the same way as this, but he's got linear cuts on the surface, and it's got, if you get complicated, it's got hyperbolic cuts on the inside of it, so it allows the linear cuts on the surface. Here I'm just using spherical cuts. This puzzle has been completely designed in Padre. Here's some of the pretty pictures that I've made with Padre to show what the interior mechanism of this puzzle would need to look like. I still need to port this puzzle over to SolidWorks to the point where I can print it. But this is one of the puzzles that's high on my to-do list. Once I build that puzzle, then I can build the puzzle that would be the bubbleoid 2-2-3 puzzle and the bubbleoid 1-3-3 puzzle. Just by varying the number of pieces I have on the edge. All I would have to change would be the cord. And this is another puzzle I really hope to get to within the near future here. Maybe I'll have this one by next year. This is a puzzle I presented on the forums back in 2010. All the work I've put into this and so far has been in Padre, so I haven't been able to print anything. But I'm calling this the real 5x5x5. This goes back to the first idea that I tried to design back in 2007. Never really thought that mechanism would work well in practice, so I knew I wanted to get back to it. And this will be a 5 by 5 by 5 cube, which has all 125 pieces playable and stickered on the surface. It would basically look like a double circle cube. And I've got pictures here showing how the layers would turn. If I turn the outer layer, just the pieces in its outside the outer circle turn. If I turn the layer below the outer layer, it turns this layer. In addition to that, it turns this ring of pieces present on the face of the puzzle. If I turn the slice layer of the puzzle, then this inner circle on the top face would turn. I've got the mechanism for this all planned out. I've got pictures of the detailed mechanism if you're interested in looking at them already on the forum. And this would be the real 5 by 5 puzzle. Once I had this puzzle, this is a stepping stone to many other puzzles I can make. The uniaxial 3 by 3 by 3s, which I showed you, they can map to the Crazy Plus puzzles, but I've only been able to make 2 of them. I can only make 2 of them because to make the rest of them, I need to be able to bandage up the inner 3 by 3 by 3 on the 5 by 5 by 5, and those pieces simply aren't present in a normal 5 by 5. This puzzle here does include those pieces. I will then be able to make some simple, basically just glue pieces together or print pieces that are already together as one piece, put them in this puzzle, and I can print the whole family of the uniaxial puzzles, where now I have deep cuts on, I can make a puzzle with 2 deep cuts on adjacent faces. They wouldn't have to be opposite faces. Or I can make a puzzle with 4 deep cut faces. And you'd be able to solve a slew of pieces with these puzzles that aren't present on the Crazy Plus series, because you'd be able to actually solve the 3 by 3 pieces on the inside as well. And the next thing that I hope this gets me to is a puzzle that's been talked about in Twisted Puzzles forum for a while, which I imagine most of you probably aren't familiar with, but it's a puzzle that we've called the complex 3 by 3 by 3. If you think about a Rubik's Cube, there's 4 types of pieces that are present. Let's look at it. Let's define the Rubik's Cube as a 3 by 3 by 3 cube where you're only able to turn the face layers. There's a type of piece that doesn't turn with any of those layers, and that's the core of the puzzle. That's not present in the face, so it never turns. You've got pieces which turn with just one face. Those are the face center pieces. All they do is rotate in position. You've got pieces that rotate with 2 adjacent faces. Those are the edge pieces on the puzzle. You've got pieces that rotate with 3 adjacent faces, and those are the corners on the puzzle. Those are the 4 types of pieces present in a Rubik's Cube. Conceptually, you can ask yourself, are those all the types of pieces that could be present in such a puzzle? And the answer is no. And the reason why it's no is you haven't looked at the pieces that turn with all the face layers. You haven't looked at the pieces that turn with 2 opposite faces. You haven't looked at the pieces that turn with 3 faces which aren't adjacent. And altogether, there's 10 types of pieces you could have. And the complex 3 by 3 is the same order puzzle that does include all 10 types of pieces. A way to visualize such a construct of a puzzle is to visualize it as a 5 by 5 by 5 puzzle that includes the inner 3 by 3. In the 5 by 5, it does have those pieces. You do have 10 types of pieces. You've got the core of the 3 by 3, you've got the edges, and the face centers of the 3 by 3, you've got the edges of the 3 by 3, you've got the corners of the 3 by 3. Those are those 4 types. In the outer 5 by 5, you've got the face center, you've got the X face center, you've got the T face center, you've got the middle edge, you've got the ring, and you've got the corner. So that gives you 10 different piece types. A way to make those 10 piece types map to the 10 piece types that would be present in the complex 3 by 3 is to tie a face center turn to a middle slice layer turn, and don't allow the layers below the face to turn at all. So if I turn this layer and the slice layer at the same time, then you can start mapping those pieces to the pieces that are present in the complex 3 by 3 by 3. I've got some ideas on how to potentially turn this puzzle into that puzzle, but I haven't got all the details worked out. I'll be happy to have this one done by next year, I think. But that's the direction I hope to take things. Again, I'd like to thank you for this opportunity to introduce myself and my puzzles. If there's any questions, feel free to shoot, and I'd be happy to answer.